Between the orbits of Mars and Jupiter lies an extraordinary region that has fascinated astronomers for over 2 centuries. The asteroid belt is far more than just a collection of space rocks. It's a cosmic museum that tells the story of our solar system's formation. Picture this, a vast expanse of space so rich that it contains millions of celestial rocks. Some are as tiny as grains of sand, while others are larger than entire cities. This remarkable region holds secrets about how our cosmic neighborhood came to be and might just hold the key to the future of space exploration. Imagine yourself floating through this celestial wonderland. As you drift between Mars and Jupiter, you'd witness a spectacular sight. Countless rocky bodies, each one a time capsule from the early days of our solar system. These ancient remnants have been dancing their cosmic ballet since the dawn of our planetary neighborhood 4.5 billion years ago. What makes this region truly special is its diversity. These space rocks come in all shapes, sizes, and compositions. Some are dark and carbon-rich, potentially carrying the building blocks of life itself. Others gleam with metallic surfaces, reflecting the sunlight like cosmic mirrors. Each one has a unique story to tell about the violent and chaotic birth of our solar system. But here's something that might surprise you. Despite what science fiction movies might have led you to believe, if you were actually traveling through the asteroid belt, you'd likely never see another asteroid with your naked eye. The space between these objects is so vast that they're typically millions of miles apart from each other. It's less like a crowded field of rocks and more like a cosmic sea with scattered islands. Welcome to the fascinating world of the asteroid belt, where every rock is a chapter in the greatest story ever told, the story of our cosmic home. Join me as we embark on an incredible journey through this celestial treasure trove, where ancient mysteries await our discovery and the secrets of our solar system's past are preserved in stone. This region isn't just a scientific curiosity. It's a testament to the boundless wonders that exist in our cosmic backyard, and perhaps a glimpse into humanity's future among the stars. Are you ready to explore this extraordinary realm? Then let's begin our cosmic adventure through the asteroid belt. Our story begins on a cold winter night in 1801, when an Italian monk named Giuseppe Piazzi was working at his observatory in Palermo, Sicily. While updating his star catalogue, he noticed something unusual, a star that seemed to be moving. Night after night, he tracked this mysterious object, carefully documenting its journey across the night sky. Little did he know, he had just made a discovery that would change our understanding of the solar system forever. This moving star turned out to be Ceres, the first and largest object ever discovered in what we now call the asteroid belt. At first, everyone thought Piazzi had found the missing planet that mathematicians had predicted should exist between Mars and Jupiter. They called this hypothetical world the missing planet, and its discovery caused quite a stir in the scientific community. But the story gets even more interesting. Shortly after Ceres was found, astronomers began discovering more objects in the same region. Heinrich Olbers discovered Pallas in 1802, Juno was found in 1804, and Vesta in 1807. Each discovery raised new questions. Were these all planets? Why were they so small compared to the other worlds we knew? The term asteroid, meaning star-like in Greek, was coined by William Herschel because through telescopes of that era, these objects appeared as mere points of light, just like stars. It was a humble beginning for what we would later realize was an entire belt of objects circling our sun. As technology advanced, our understanding of the asteroid belt grew dramatically. The invention of photography in the 19th century revolutionized asteroid discovery. What once took careful visual observation could now be captured on photographic plates, allowing astronomers to find dozens, then hundreds, and eventually thousands of new asteroids. The real breakthrough came with the space age, When we started sending spacecraft to explore these distant rocks up close, we discovered a whole new world of wonders. The NASA Dawn mission, for instance, gave us our first detailed looks at Ceres and Vesta, revealing them to be complex worlds with their own geological histories. Ceres, we now know, even has a subsurface ocean of briny water. Think about this. Every time we look at the asteroid belt with better technology, we find something new and amazing. From Piazzi's simple telescope to modern space probes, each advancement in technology has peeled back another layer of mystery. These aren't just random rocks in space. They're like cosmic time capsules, preserving the conditions of our early solar system. Today, we understand that the asteroid belt isn't a failed planet at all. It's something far more fascinating. It's a collection of leftovers from the solar system's formation, material that never came together to form a planet because of Jupiter's powerful gravitational influence. Each piece tells part of our cosmic origin story, waiting to be discovered and understood. And who knows, as our technology continues to advance, what other secrets might we uncover in this remarkable region of space? The story that began with a curious monk in Sicily continues to unfold, reminding us that some of the greatest discoveries in science often start with a simple observation and a lot of curiosity. Let's take a closer look at what makes the asteroid belt truly unique. Imagine taking a journey from the Sun, passing by Mercury, Venus, Earth, and Mars. Just beyond Mars, between 2.2 and 3.2 astronomical units from the Sun, you'll find this fascinating cosmic highway. To put that in perspective, if the Sun were in New York City, the asteroid belt would stretch roughly from Chicago to Denver. Now, you might think this region is incredibly crowded, like in science fiction movies. But here's a fascinating truth. If you combined all the asteroids in the belt, they would only add up to about 4% of our moon's mass. That's surprisingly small, isn't it? It's like taking our moon, breaking it into tiny pieces, and then making those pieces even smaller until they're just 4% of the original. But don't let that small mass fool you. The belt is home to an incredible number of objects, more than 1 million rocks, larger than 1 kilometer across. That's like having 1 million mountains floating in space, and these aren't just ordinary space rocks. They come in 3 main varieties, each telling its own story about our solar system's history. First, we have the carbonaceous asteroids, which make up about 75% of all known asteroids. These dark, carbon-rich rocks are like time capsules from the early solar system. They contain water ice and organic compounds, the basic ingredients that might have helped life begin on Earth. Imagine them as cosmic delivery trucks that might have brought water to our planet billions of years ago. Then there are the silicate asteroids, similar to the rocks you might find in Earth's crust. These space rocks are like cosmic cousins to our planet's mountains and valleys. They're usually found in the inner part of the belt, closer to Mars, where the sun's heat has baked away most of their ice and volatile materials. Finally, we have the metallic asteroids, which are perhaps the most intriguing of all. These rare objects are made mostly of iron and nickel, similar to Earth's core. Some scientists believe they might be the exposed hearts of ancient planetesimals that were broken apart in massive collisions billions of years ago. They're like cosmic treasure chests, potentially worth trillions of dollars in precious metals. Here's something that might blow your mind. Despite having over 1 million large objects, the asteroid belt is mostly empty space. If you were flying through it in a spacecraft, you'd have to try really hard to hit an asteroid. The average distance between these space rocks is about 600,000 miles. That's like having just 2 marbles floating in an entire football stadium. The belt's structure isn't random either. Jupiter's massive gravitational influence has carved out empty zones called Kirkwood gaps, creating cosmic highways where few asteroids dare to travel. It's like Jupiter is the traffic cop of the solar system, keeping these space rocks in check and maintaining order in what might otherwise be cosmic chaos. Understanding these fundamental characteristics isn't just about satisfying our curiosity. It's crucial for future space exploration and potentially even the survival of our species. These asteroids could one day serve as stepping stones for deeper space exploration, sources of precious resources, or even places to establish space colonies. They're not just rocks in space. They're our cosmic neighbors and perhaps the key to humanity's future among the stars. Let's meet the most remarkable residents of the asteroid belt, starting with the queen of this cosmic neighborhood, Ceres. Named after the Roman goddess of agriculture and fertility, Ceres is truly in a class of its own. It's so massive that it makes up nearly 1/3 of the entire belt's mass. This dwarf planet is the only one of its kind in this region, and it holds a fascinating secret. Beneath its cratered surface lies an ocean of salty water. Just imagine, a hidden ocean floating between Mars and Jupiter. When NASA's Dawn spacecraft visited Ceres in 2015, it discovered mysterious bright spots on its surface. These turned out to be deposits of salt left behind by water that had seeped up from below. It's like finding an oasis in the middle of a cosmic desert. Next on our tour is Vesta, the jewel of the asteroid belt. If Ceres is the queen, then Vesta is the belt's bright knight, reflecting about 40% of the light that hits it, making it the brightest asteroid visible from Earth. In fact, on a clear night you can sometimes spot Vesta with your naked eye. This massive rock has a fascinating story to tell. It's more like a baby planet that never quite made it to full size. It has a metal core, a rocky mantle, and a surface scarred by enormous impact craters, including one so large it takes up most of Vesta's southern hemisphere. Then we have Pallas, named after Athena's title of Pallas in Greek mythology. This giant is unique because of its highly tilted orbit. It's like a cosmic rebel that refuses to follow the same path as its neighbors. Scientists think this unusual orbit might be the result of a massive collision in the distant past. Pallas is so large that if you could stand on its surface, you would experience about 2% of Earth's gravity. Enough to hold you down, but light enough that you could jump incredibly high. Hygeia, named after the Greek goddess of health, rounds out our tour of the belt's giants. While it's the fourth largest object in the belt, it's also one of the most mysterious. Recent observations suggest that Hygeia might be the result of a massive collision that completely shattered an even larger ancient asteroid. It's like a cosmic phoenix, reborn from the fragments of a catastrophic impact. The naming of asteroids has become quite an interesting story in itself. In the early days, astronomers named them after gods and goddesses from Greek and Roman mythology, following the tradition used for naming planets. But as more and more asteroids were discovered, they started running out of deity names. Today, asteroids can be named after almost anything or anyone, from scientists and artists to cities and even pop culture references. There's even an asteroid named Beatlemania, honoring the famous band. Another one is called Mr. Spock, not after the Star Trek character, but actually named after the discoverer's cat. And yes, there's one called Wikipedia. The only rule is that the name must be approved by a special committee of the International Astronomical Union. Some of the most touching names are those given to asteroids in honor of people who have made significant contributions to science or humanity. For instance, there's an asteroid named Malala, after the young Pakistani activist Malala Yousafzai, and another called Copernicus, honoring the revolutionary astronomer. These largest residents of the asteroid belt are like the guardians of countless smaller objects, each with its own unique characteristics and story. They're not just random rocks floating in space. They're ancient worlds that have witnessed the entire history of our solar system, from its violent birth to the present day. As we continue to study these fascinating objects, who knows what other secrets they might reveal about our cosmic neighborhood? The asteroid belt isn't just a random collection of space rocks. It's an intricate cosmic dance floor where gravitational forces create fascinating patterns and empty zones. Let me tell you about one of the most intriguing features, the Kirkwood Gaps, named after Daniel Kirkwood, who discovered them in 1866. Imagine the asteroid belt as a massive vinyl record, with the Kirkwood Gaps being like empty grooves where almost no asteroids dare to travel. These gaps aren't random. They're created by Jupiter's powerful gravitational influence. It's as if Jupiter is conducting a cosmic orchestra, and certain orbital distances are forbidden notes in the solar system's symphony. Speaking of Jupiter, let's talk about this cosmic giant's role as the belt's master choreographer. Jupiter is like a celestial bouncer, its massive gravitational pull keeping the asteroid belt in check. Without Jupiter's influence, the asteroid belt might have formed into another planet billions of years ago. Instead, Jupiter's gravity was so strong that it prevented these rocks from coming together, while also protecting them from being scattered across the solar system. Here's something fascinating. Jupiter's gravity can actually fling asteroids out of their usual orbits. Sometimes these space rocks end up in what we call resonant orbits, where they complete a certain number of orbits around the Sun for every orbit Jupiter makes. It's like a cosmic game of musical chairs, with Jupiter setting the rhythm. But the asteroids aren't just dancing with Jupiter, they're also interacting with each other. When asteroids collide, they can create families of smaller asteroids that share similar orbital paths and compositions. Imagine throwing a ceramic plate on the ground. All the pieces would share the same material, but now they're separate entities. That's similar to what happens when asteroids collide. These collisions happen more often than you might think, though they're usually more like gentle bumps than catastrophic crashes. Over millions of years, these interactions have created distinct groups of asteroids that astronomers can trace back to their parent bodies. It's like cosmic genealogy. Sometimes, these interactions can send asteroids on new adventures. A small bump here, a gravitational nudge there, and an asteroid might find itself on a completely different path. Some even end up visiting Earth's neighborhood. These are the near-Earth asteroids we often hear about in the news. The structure of the belt itself is remarkably organized, despite its chaotic appearance. The main belt is divided into distinct regions, each with its own character. The inner belt tends to have more rocky, metallic asteroids, while the outer regions are home to darker, more primitive objects rich in carbon and ice. It's like a cosmic sorting system, with different types of asteroids finding their preferred neighborhoods. Perhaps one of the most mind-bending aspects of the belt's dynamics is its age. These patterns and interactions have been playing out for over 4 billion years, yet the dance continues to evolve. New collisions create new asteroid families. Jupiter's gravity keeps maintaining the Kirkwood Gaps, and the cosmic ballet goes on. If you're as fascinated by these cosmic dynamics as I am, I'd love to know, which asteroid would you most like to visit if you could? Would you choose Ceres to explore its mysterious bright spots? Or perhaps Vesta to stand on its massive impact crater? Let me know in the comments below. And if you want to keep exploring the wonders of our universe together, don't forget to subscribe to Exploring the Universe. Hit that like button if you enjoyed learning about the belt's incredible dynamics, and stay tuned for our next cosmic adventure. Remember, every time you look up at the night sky, you're witnessing this amazing celestial dance that's been going on for billions of years. Isn't our universe simply amazing? The asteroid belt is like a cosmic time capsule, preserving the original building blocks of our solar system from over 4.5 billion years ago. Imagine having a perfectly preserved museum where nothing has changed since the time when our planets were first forming. That's exactly what we have in the asteroid belt. These ancient space rocks are like the pages of a cosmic history book, and scientists are the eager readers trying to decode their stories. Unlike the planets, which have gone through massive changes due to geological activity and atmospheric processes, many asteroids remain virtually unchanged since their formation. They're like frozen snapshots of our solar system's infancy. Think about this. When you hold a meteorite that came from the asteroid belt, you're literally touching material that's older than any rock you could find on Earth. These pristine samples contain organic compounds, precious metals, and even water ice that date back to the very beginning of our cosmic neighborhood. It's like having a direct line to call back in time. The belt also gives us crucial clues about how planets form. By studying these leftover building blocks, scientists can piece together the puzzle of planetary formation. It's like finding the instruction manual for building solar systems. We've learned that planets don't just pop into existence. They grow through countless collisions between smaller bodies, gradually building up from dust to pebbles to planets. Here's something fascinating. Some asteroids contain amino acids, the building blocks of life as we know it. This discovery has led scientists to wonder if the ingredients for life on Earth might have been delivered by ancient asteroid impacts. We might literally be made of star stuff that was transported here by these cosmic messengers. The asteroid belt also serves as nature's own collision laboratory. By observing impacts between asteroids, scientists can better understand the physics of planetary collisions. These cosmic crash tests happen at speeds of tens of thousands of miles per hour. Try setting that up in a lab on Earth. When astronomers spot a new crater or witness an asteroid breaking apart, they're watching the same processes that shaped our entire solar system. These collisions can create asteroid families, groups of smaller asteroids that were once part of a larger body. By studying these families, scientists can understand how planets and moons might have broken apart or come together in the early solar system. It's like watching the process of planetary formation in reverse. The belt also helps us understand the role of Jupiter in our solar system's architecture. The giant planet's gravity has been influencing the belt for billions of years, creating patterns that tell us about the early migration of the planets. Some scientists think Jupiter might have once moved closer to the Sun before settling in its current orbit, and the evidence for this cosmic dance is preserved in the structure of the asteroid belt. Perhaps most importantly, studying the belt helps us prepare for potential future impacts on Earth. By understanding the composition, orbits, and behavior of asteroids, we're better equipped to protect our planet from any dangerous space rocks that might come our way. It's like having an early warning system built into our solar system. The scientific value of the asteroid belt extends beyond our solar system too. As we discover more planetary systems around other stars, what we learn from our own asteroid belt helps us understand how common or rare our solar system might be in the cosmic scheme of things. Are asteroid belts common around other stars? Do they play the same crucial role in delivering water and organic materials to planets? These are questions we're beginning to answer thanks to our studies of our own cosmic debris field. Every new mission to the asteroid belt, every new telescope observation, and every meteorite we study adds another piece to this grand cosmic puzzle. We're not just studying space rocks, we're uncovering the story of our own origins, written in the language of ancient stones that have been floating in space since before Earth was even born. Now that's what I call a truly astronomical discovery. When it comes to exploring the asteroid belt, humanity has made remarkable strides in recent decades. Let me take you through some of our most ambitious missions and the incredible challenges we've faced along the way. The Dawn mission, launched by NASA in 2007, made history as the first spacecraft to orbit not just one, but two objects in the asteroid belt. Think about that for a moment. A human-made machine traveling billions of miles to study both Vesta and Ceres in detail. Dawn revealed that Vesta is a dry, rocky world with an ancient surface, while Ceres harbors a subsurface ocean and mysterious bright spots made of salt deposits. Then there's OSIRIS-REx, one of our most daring missions yet. While not strictly an asteroid belt mission, since it visited Bennu, a near-Earth asteroid, it demonstrated the technologies we'll need for future asteroid belt exploration. In October 2020, it performed something unprecedented. It actually touched down on an asteroid's surface to collect samples. Just imagine the precision needed to land on a rock, tumbling through space. But exploring the asteroid belt isn't like driving a car down a highway. Our spacecraft face incredible challenges. First, there's the issue of navigation. Asteroids don't just sit still. They rotate, tumble, and move in their orbits. Our spacecraft needs sophisticated tracking systems just to keep up with their targets. Then there's the matter of distance. Radio signals from Earth can take up to 30 minutes to reach a spacecraft in the asteroid belt. This means our probes need to be largely autonomous, capable of making split-second decisions without waiting for instructions from home. We've developed amazing technologies to study these space rocks. Ground-based telescopes equipped with adaptive optics can cut through Earth's atmospheric distortion to give us sharp images. Space-based observatories like the James Webb Space Telescope can study the chemical composition of asteroids by analyzing their infrared signatures. One of the most fascinating tools in our arsenal is radar imaging. By bouncing radio waves off asteroids, we can create three-dimensional maps of their surfaces and even peek inside them. It's like giving these ancient rocks a cosmic CT scan. The future of asteroid belt exploration looks even more exciting. New missions are being planned that will use innovative propulsion systems, advanced AI, and even swarms of small spacecraft working together. Some engineers are even designing spacecraft that could hop from asteroid to asteroid, turning these space rocks into stepping stones across our solar system. But perhaps the most thrilling prospect is the development of asteroid mining technology. These rocks aren't just scientific treasures, they're potential resources for future space exploration. Some asteroids contain more precious metals than we've ever mined on Earth, while others might provide water that could be split into hydrogen and oxygen for spacecraft fuel. Every mission we send teaches us something new, not just about the asteroids themselves, but about our place in this vast cosmic neighborhood. As we continue to explore, who knows what other secrets the asteroid belt might reveal? Now, let me share some fascinating facts about the asteroid belt that might blow your mind. Trust me, these aren't your typical space facts. Let's start with something that sounds like science fiction, the most valuable asteroid ever discovered. Meet 16 Psyche, a metallic world that's literally worth more than the entire global economy. This massive chunk of metal, mainly composed of iron and nickel, is estimated to be worth around $10 quintillion. That's a 10 followed by 18 zeros. Some scientists believe it might be the exposed core of an ancient protoplanet that lost its outer layers in violent collisions billions of years ago. NASA is so intrigued by 16 Psyche that they're sending a mission to study it up close. But here's something really cool. Have you ever wondered what the sky would look like if you were standing on an asteroid in the belt? Well, it's nothing like those crowded scenes from Star Wars. From any asteroid in the belt, the sky would actually look pretty empty. The nearest large asteroid would probably appear as just a tiny dot of light, as these objects are typically millions of kilometers apart. However, you'd get an amazing view of Jupiter, which would appear much larger than it does from Earth. And the Sun, while smaller than what we see from Earth, it would still be the brightest object in the sky, casting sharp, dark shadows across the asteroid's rocky surface. Speaking of spacing, there's a common misconception that the asteroid belt is a densely packed region where spacecraft need to dodge rocks constantly. The reality is quite different. The belt is actually incredibly sparse. If you combined all the asteroids in the belt into a single body, it would be smaller than our moon. The average distance between large asteroids is about 1 million kilometers. That's why spacecraft like Dawn, Voyager, and others have crossed the asteroid belt without any problems. No fancy maneuvering required. Now let me tell you about one of the belt's most intriguing mysteries, binary asteroids. These are pairs of asteroids that orbit each other while simultaneously orbiting the Sun, like cosmic dance partners. We've discovered that about 15% of asteroids larger than 200 meters in diameter have a companion. The most famous binary pair is 287 Sylvia and its two moons, nicknamed Romulus and Remus, after the legendary founders of Rome. But here's the fascinating part. How did these pairs form? Some scientists think they're leftovers from massive collisions, while others suggest that the Sun's radiation can cause a single asteroid to split in two over time through something called the Yorp effect. One particularly interesting binary system is 617 Patroclus and its nearly equal-sized companion, Menoetius. These two asteroids have been dancing together for billions of years, and studying them might help us understand how the early solar system evolved. They're like time capsules, preserving information about conditions when planets were still forming. The more we study these celestial oddities, the more we realize how dynamic and complex the asteroid belt really is. It's not just a collection of lifeless rocks. It's a region full of fascinating phenomena that challenges our understanding of the solar system. The future of asteroid exploration isn't just exciting, it's absolutely mind-blowing. Let me paint you a picture of what's coming in the decades ahead. Imagine massive space factories processing precious metals extracted from asteroids. This isn't science fiction anymore. Space mining is rapidly becoming a reality. Companies are already developing technologies to extract valuable resources from asteroids. We're talking about platinum, gold, and rare earth elements in quantities that could make Earth's richest mines look like pocket change. But perhaps the most valuable resource isn't the precious metals. It's water. Water from asteroids could be split into hydrogen and oxygen for rocket fuel, essentially turning the asteroid belt into a network of cosmic gas stations for deep space missions. But here's where it gets really interesting. Some scientists and engineers are designing plans for permanent bases inside large asteroids. Yes, you heard that right. Inside asteroids, these natural space rocks could protect human settlers from radiation and micrometeorites, while their low gravity would make mining operations easier. Picture a base carved into asteroid Ceres, with hydroponic gardens growing food using water extracted from the dwarf planet's ice deposits. Some asteroids even rotate at a rate that could create artificial gravity along their equators, potentially solving one of the biggest challenges of long-term space habitation. However, with great power comes great responsibility. As we plan these ambitious projects, we must consider planetary protection. This isn't about defending Earth from asteroid impacts, though that's important too. It's about preventing biological contamination in both directions. We need to ensure that our exploration doesn't destroy potential evidence of past or present microbial life that might exist in water-rich asteroids. Some scientists believe that studying pristine asteroids might help us understand how life began on Earth, so we need to be careful not to contaminate these cosmic time capsules. Speaking of exploration, the next decade is going to be incredible for asteroid missions. NASA's Psyche mission is heading to the metallic asteroid 16 Psyche, which could be the exposed core of an ancient protoplanet. The Lucy mission will visit 8 different asteroids, including 7 Trojan asteroids that share Jupiter's orbit. These missions will use cutting-edge technology like solar electric propulsion, advanced imaging systems, and artificial intelligence for navigation. Japan's space agency JAXA is planning follow-up missions to their successful Hayabusa programs, while the European Space Agency is developing technologies to capture and redirect asteroids. Private companies are getting in on the action too, with plans for everything from asteroid mining operations to tourist visits to near-Earth asteroids. One of the most ambitious proposals involves creating a network of small spacecraft that would act like a cosmic internet, facilitating communication and navigation throughout the asteroid belt. Imagine swarms of small robots working together to map, study, and eventually mine asteroids, all coordinated through this space-based network. The technologies we develop for asteroid exploration won't just help us understand our solar system, they could help solve problems on Earth too. Techniques for extracting water from asteroids might help us develop better water purification systems. Mining technologies could become more efficient and environmentally friendly. And the materials we bring back from space could revolutionize industries from electronics to medicine. We're standing at the threshold of a new space age where the asteroid belt isn't just a scientific curiosity, it's humanity's next frontier. The question isn't if we'll establish a permanent presence in the asteroid belt, but when. The asteroid belt has captured human imagination in ways that few other cosmic features have. Let's explore how these space rocks have shaped our culture, our safety concerns, and potentially our future as a species. Hollywood has certainly fallen in love with asteroids. From classic films like Deep Impact and Armageddon to more recent productions like Don't Look Up, asteroids have played starring roles in our entertainment. But it's not just movies. Asteroids appear in countless video games, books, and TV shows. Remember that iconic scene in Star Wars, The Empire Strikes Back, where the Millennium Falcon navigates through an asteroid field? While we now know the real asteroid belt isn't nearly that crowded, these portrayals have helped millions of people connect with space science. Science fiction authors have been particularly creative with the asteroid belt. In the beloved book series, The Expanse, asteroid settlements become crucial players in humanity's future, with miners called belters developing their own culture and even their own dialect. These stories help us imagine what human civilization might look like when we finally establish permanent communities among the asteroids. But let's talk about something more immediate: planetary defense. The dinosaurs probably wish they had a planetary defense system 65 million years ago, while the asteroid belt itself rarely poses a direct threat to Earth. Studying it helps us better understand how to track and potentially deflect dangerous space rocks. NASA's DART mission recently proved we can actually change an asteroid's path if needed. That's literally planetary defense in action. This wasn't just a scientific achievement, it was humanity's first real step toward protecting ourselves from the kind of impact that doomed the dinosaurs. The asteroid belt also serves as a constant reminder that we live in a dynamic solar system. Every meteorite we find on Earth tells a story that connects us to these ancient space rocks. Did you know that some scientists believe the water in Earth's oceans might have been delivered by ancient asteroid impacts? The same process that once helped make our planet habitable could now help us explore beyond it. Speaking of exploration, asteroids might hold the key to humanity's future in space. These rocks are like cosmic hardware stores, packed with everything we need for space colonization. Water for drinking and making rocket fuel? Check. Metals for building spacecraft and habitats? Check. Rare elements for electronics and solar panels? Check again. Some asteroids even contain organic compounds similar to the building blocks of life. The economic potential is staggering. A single metal-rich asteroid could contain more platinum group metals than have ever been mined in human history. But more importantly, asteroid resources could help us solve problems on Earth. Instead of mining our planet's dwindling resources and damaging fragile ecosystems, we could obtain raw materials from space. This could revolutionize how we think about environmental conservation and sustainable development. There's also something profound about how the asteroid belt connects us to our cosmic history. These rocks have remained largely unchanged since the birth of our solar system. By studying them, we're literally touching pieces of our origin story. Every time we send a probe to an asteroid or analyze a meteorite, we're reading another page in the book of how our world came to be. The asteroid belt reminds us that we're part of something much bigger than ourselves. It challenges us to think beyond our everyday concerns and consider our place in the cosmos. As we continue to explore and understand these ancient rocks, we're not just learning about space. We're learning about ourselves and our potential as a spacefaring civilization. As we wrap up our journey through the asteroid belt, I hope you've come to see these cosmic rocks in a new light. What might have seemed like just a scattered collection of space debris is actually an incredible archive of our solar system's history, preserved in the cold vacuum of space for 4.5 billion years. Each asteroid is like a time capsule, holding secrets about how our cosmic neighborhood came to be. From the water that might have helped make Earth habitable to the metals that could fuel our journey to the stars, these ancient rocks have so many stories to tell. They're not just relics of the past, they're guideposts to our future. Whether we're talking about establishing the first asteroid mining operations, building bases inside these space rocks, or using them as stepping stones to explore the outer solar system, the asteroid belt represents humanity's next great frontier. It's amazing to think that the same objects that once fascinated ancient astronomers might now hold the key to becoming a truly spacefaring civilization. The more we learn about the asteroid belt, the more we realize how interconnected everything in our solar system truly is. These rocks have influenced Earth's history, from possibly helping deliver the building blocks of life to occasionally reminding us of our cosmic vulnerability through dramatic impacts. Now, as we develop the ability to study and eventually utilize these resources, we're writing the next chapter in this ongoing cosmic story. So the next time you look up at the night sky, remember that between Mars and Jupiter lies a realm of endless possibilities, waiting for humanity to explore its mysteries. Who knows? Perhaps someday some of you watching this video will be among the first humans to set foot on an asteroid. And speaking of exploration, I'd love to continue this cosmic journey with you. If you've enjoyed learning about the asteroid belt today, make sure to hit that subscribe button and turn on notifications by clicking the bell icon. This way, you won't miss any of our upcoming adventures through space. Exploring the universe brings you fresh astronomy content every week, from the mysteries of black holes to the latest discoveries on Mars. Don't forget to give this video a thumbs up if you learned something new today, and share it with your friends who love space as much as we do. You can also follow our journey across social media, where we share amazing space facts, beautiful astronomical images, and breaking news from the world of space exploration. Thank you for joining me on this exploration of the asteroid belt. Remember to look up and keep wondering. The universe is full of amazing discoveries waiting to be made. See you in our next cosmic adventure.